A raindrop falls from the sky at about 20 miles per hour. It weighs roughly a gram, barely enough to feel on your skin. Now, what if that raindrop was the size of a car? Let's just say you'd feel it. First, let's talk about why raindrops don't get this big naturally. As a raindrop falls, it collides with air molecules. Small drops are held together by surface tension, the same force that lets you overfill a glass of water slightly. But surface tension has limits. Once a raindrop exceeds about 5 millimeters, roughly the size of a housefly, it becomes unstable. The air pressure flattens it into a pancake and then it breaks apart. Physics says no. But we're not here to listen to physics. We're here to break it. So let's magically hold our car-sized raindrop together and see what happens. A typical car weighs about 2,500 kilograms. Our raindrop? Let's calculate. A sphere of water with a 1.5 meter diameter, roughly car length, would weigh approximately 1,167 kilograms. That's heavier than the car itself. Almost 2 metric tons of water suspended in the sky, about to fall on your head. For reference, that's the weight of a grand piano. No, wait, 2 grand pianos, stacked. Now, how fast would this thing fall? Normal raindrops max out at about 20 miles per hour because air resistance balances their weight. This is called terminal velocity, but our megadrop is different. It has way more mass relative to its surface area. Running the numbers, a car-sized raindrop would reach a terminal velocity of roughly 150 to 200 miles per hour. That's faster than a skydiver, faster than most highway speed limits. About the speed of a Category 5 hurricane wind, and it's heading straight down. Let's talk about what happens when it lands. A 1,167 kilogram mass traveling at 180 miles per hour carries approximately 5.7 megajoules of kinetic energy. That's equivalent to about 1.3 kilograms of TNT. When the drop hits the ground, all that energy has to go somewhere. The water would splash outward at hundreds of miles per hour. The shockwave would shatter windows. Car alarms would trigger for blocks. And at the center of impact? A crater. Not huge, maybe a meter deep. But definitely enough to ruin your lawn. And here's the thing. This is one raindrop. Imagine a storm. So, the next time you complain about getting caught in the rain, remember that physics is doing you a favor. Surface tension, air resistance, and basic fluid dynamics are working together to make sure raindrops stay the size of flies instead of the size of cars. The universe is full of things that could kill you. Rain isn't one of them, usually.